We'll look at one more example of tree diagrams, and one neat trick that we can use whenever we have the case of at least one, and that always applies. So this is our problem. A choir contains 15 girls and 9 boys. The choirmaster randomly selects 4 singers from the choir to be interviewed by a newspaper. Find the probability that at least one boy is in the 4 singers selected. So with any text problem, we start by just picking out the key information here. So we have 15 girls, we have 9 boys. We have to randomly select 4 singers. Find the probability that at least one boy, and this is a key piece of information, is in the 4 singers selected. So whenever we see that phrase, at least one, some alarm bells should go off, and we always use the same approach to solve these problems. Now, the basis of what we're going to utilize here is that if you have a set A, and we can talk about the probability of A, then we know that if we add the complement to A, the probability of the complement, that would always be 100% or 1. Now this would be equivalent to saying that the probability of an event is equal to 1 minus the probability of its complement, and that's the part we want to use. If we apply this to our problem, and we say that, okay, the event A is that we have at least one boy. Now, what would A complement be then? Well, if you don't have at least one boy, you have no boys, which is the same as only girls. So when we want to find the probability of at least one boy, we're really what we should do is we need to look for 1 minus the probability of all girls. And now we can set this up as a series of trials. And let's remind ourselves, what are we asked to find? We're asked to find the probability that at least one boy is in the 4 singers selected. So we're selecting 4 boys, and that's why we set this up as 4. Sorry, we're selecting 4 singers. So we set this up as 4 trials. And in the first trial, we make a random pick, and we're going to pick either a boy or a girl. That's the first pick, and this is random. So now we want to look at the probability that our first choice is a boy. So how many boys are there? Well, there are 9 boys, and there are 24 singers altogether. So the probability that the first pick is a boy is 9 out of 24. And the probability that the first pick is a girl is 15 out of 24, because there are 15 girls in the choir. Now, the next part is important. And we're not really concerned about the probability for picking boys, because we wanted to find the probability that we're only selecting girls. So our second pick, we could look at, if we already chose one girl, then the next situation is, okay, the second pick is either going to be a boy or a girl. We have to think how many girls are left, because we already chose one. So how many girls are left? Well, there are 14 girls left. And remember, we already selected one out of the 24. So altogether in the choir, there are 23 girls left. And I'll just separate the different picks with these red lines here. So every section is sort of a new experiment or new pick. And our third pick is either going to be a boy or a girl. And how many girls are left now? We've already picked out 2 girls. So there are 13 girls left. And since we picked out 2 overall, there are 22 choir members left to choose from. So the probability is 13 out of 22. And the very last pick is either a boy or a girl. And if we already picked out 3 girls, there are 12 left and 21 to choose from. Now, if we multiply these probabilities together, we're going to get the probability of girl and girl and girl and girl, like this. And so the probability that we wanted to find was the probability of at least one boy. That's going to be equal to 1 minus 15/24 multiplied with 14/23 multiplied with 13/22 multiplied with 12/21. And if you work that all out, that's going to be around 0.872 with 3 significant figures, which is 87.2% if you want it as a percentage.